Let's solve this integral using the Euler substitution, right? As you might know, this function, the ln of x plus the square root of x squared plus 1, this one is the sine hyperbolic inverse of x, right? So instead of integrating this function, you can integrate the sine hyperbolic inverse of x, this one using integration by parts. And when you do this, the answer to this one is x ln of x plus the square root of x squared plus 1, and then minus the square root of x squared plus 1 plus the constant of integration. So this is how to integrate this, but we are going to solve this one using the Euler substitution, right, to see whether we'll get the same answer here. So let's do that. So Euler substitution, we are going to let this radical, the square root of x squared plus 1, to be equal to t minus x, right? So when we do that, we square both sides. We have x squared plus 1 to be equal to, squaring this is going to be t squared minus 2tx plus x squared. And when we do that, x squared is going to cancel x squared, and then what you are left with is 2tx equal to t squared minus 1. So try to isolate x. X is going to be t squared minus 1 all over 2t, right? So this is what we have for x. So in place of x, I'm going to replace it with that. Now let's find an expression for the square root of x squared plus 1 in terms of t. So square root of x squared plus 1 is t minus x, and x is this guy, right? So x is t squared minus 1 all over 2t, like this, and this is equals to 2t squared minus t squared plus 1 all over 2t, which is equal to t squared plus 1 all over 2t. This is the same as the square root of x squared plus 1. Now an expression for dx, right? So because we have to find everything in terms of t, correct? So to find an expression for dx, we have to differentiate this one using the quotient rule. So dx dt is going to be equal to v du, and differentiate u, which is 2t, minus u dv, and differentiate v, that is 2 divided by v squared, which is 4t squared. That is the denominator squared. So dx dt is going to be equal to what? So here is going to be 4t squared minus 2t squared plus 2 all over 4t squared, and this is equals to 2t squared plus 2 all over 4t squared, and this is equals to 2 out t squared plus 1 all over 4t squared. So that means that dx is going to be equal to t squared plus 1 dt divided by 2t squared, because this will cancel that, leaving 2. Cool. Now let's take the integral into the t world. I is going to be the integral of the ln of x, right? So the integral of the ln of x, so x, we know x to be this, that is t squared minus 1 over 2t, t squared minus 1 over 2t, plus the square root of x squared plus 1. The square root of x squared plus 1 is this guy, which is t squared plus 1 over 2t, times dx, and dx is this, which is t squared plus 1 all over 2t squared dt. Cool. So I here is going to be equal to the integral of the ln of, so the denominators are the same, so we just have to sum the numerators, which is going to sum to 2t squared all over 2t. This is multiplied by, this is 1/2, is a constant, and then you can bring it out in front here, and then you have t squared plus 1 all over t squared dt. Let's simplify this integral. This is going to be 1/2 the integral of the ln of, this is now left with t, so 2t squared over 2t is t, and then here we are going to have 1 plus 1 over t squared dt. That is simplifying this. Alright, so I am now going to distribute in the ln of t, so that is going to be the integral of the ln of t plus the ln of t multiplied by 1 over t, all this one dt, like this. And now let's split this integral into two different integrals. This is 1/2 the integral of the ln of t dt plus 1/2 the integral, this is t squared, I beg your pardon, the integral of the ln of t multiplied by 1 over t squared dt. Alright, so I am now going to call this one integral I1 and then the second one integral I2 and tackle them one after the other. So integral I1, this one we can easily integrate this, but I'm going to show you how to do that using integration by parts, right? So I1 is just the integral. I'm doing that without the 1/2 in front, the ln of t dt, right? So let's do integration by parts here. So I'm going to do the di method. So we have the d and I, d for differentiation and I for integration. I am going to differentiate the ln of t, and what is left is just 1. So plus, next one is minus, differentiating ln of t is 1 over t, and integrating 1 in the t world is t. So when we multiply terms diagonally, there is no integral, but when we multiply terms horizontally, we have to take the integral. So this has become trivial. So integrating this one is now diagonal terms is t ln of t, and then minus, because of this guy here, the integral, because I'm multiplying terms horizontally, 1 over t times t dt. So I1 is going to be equal to t ln of t, and then minus, this will cancel that, leaving 1. So integrating 1 in the t world is t. So this is integral I1. Now let's tackle integral I2, right? So I'm going to clean this one up and then we'll deal with the I2 there. So the I2 is this. I2 is the integral of the ln of t. This is multiplied by 1 over t squared dt. So the same integration by parts. So di. So I'm going to differentiate again ln of t. So this is plus, next one is minus, and I'm going to integrate 1 over t squared. So differentiating ln of t is 1 over t, and integrating 1 over t squared is negative 1 over t. So diagonal terms, there is no integral, remember that, but multiplying terms horizontally, we have to take the integral. So I2 here is going to be equal to, diagonal terms is going to be negative 1 over t times the ln of t, and then minus minus, that's become positive, right? Because we are multiplying terms horizontally, we have to take the integral of 1 over t times 1 over t dt. So I2 is going to be equal to negative 1 over t ln of t plus the integral of 1 over t squared dt. So I2 is going to be equal to negative 1 over t ln of t, and integrating 1 over t squared is negative 1 over t. So this is the integral for I2. Now we can now sum them, right? You see that I is equals to half times I1 plus half times I2, right? So 1/2 times I1, which is t ln of t minus t, plus 1/2 times I2, and I2 is negative 1 over t ln of t minus 1 over t. You are done. You can put the constant of integration. Why not? I is going to be equal to, distribute in half, 1/2 t ln of t minus 1/2 t, plus the same thing here, minus 1/2 times 1 over t ln of t minus 1/2 times 1 over t, plus the constant of integration. I'm going to bring the ln of t together. So I'm going to have I to be equal to 1/2 ln of t is common between this and this, right? So when I do that, that is going to be left with this is going to be left with t minus 1 over t. Minus 1 over t. Right, and I'm going to bring this and this together, and they have 1/2 in common, right? So we factorize 1/2 out minus, and this is going to be t plus 1 over t, like this, plus the constant of integration. So we are done. So but we have to move back into the x world. So go back to our initial substitution. So here the square root of x squared plus 1 is equal to t minus x. Right, So that is what we have. So recall our substitution that the square root of x squared plus 1 is equal to t minus x. So we can find an expression for t here in terms of x. So t is going to be equal to x plus the square root of x squared plus 1. So we just replace t with that in our integral. So I is going to be 1/2 ln of t. So in place of t is going to be x plus the square root of x squared plus 1, like this. And then multiplied by t minus 1 over t, which is x plus the square root of x squared plus 1 minus 1 all over x plus the square root of x squared plus 1, like this. Alright, and then minus 1/2 into t plus 1 over t. T is x plus the square root of x squared plus 1, and then plus 1 all over t. T is x plus the square root of x squared plus 1, like this, plus the constant of integration. So what I'm going to do here, I am going to call this one in this bracket a and call this one b. I'm going to simplify them out, and then I'll just come and replace them in our integral to see whether it will match our initial answer. Now calculus is done. Now let's deal with this algebra. So a is going to be equal to x plus the square root of x squared plus 1, right, minus 1 all over x plus the square root of x squared plus 1. Okay, so here what I'm going to do is to rationalize this radical. So that is going to be multiplied by x minus the square root of x squared plus 1 all over x minus the square root of x squared plus 1, like this. So a is going to be equal to x plus the square root of x squared plus 1, and then minus, you can put this one in parentheses like this. So when we multiply the top, that is going to be x minus the square root of x squared plus 1. And at the bottom, the difference of two squares, when we multiply, that is going to be the square of the first one, x squared, minus the square of the second one, and the second one is the square of the square root of x squared plus 1, which is x squared plus 1, like this. Cool. So a is going to be equal to x plus the square root of x squared plus 1 minus this one is going to be equal to, when we simplify this, that is going to be x minus the square root of x squared plus 1, like this, divided by this is going to be -1, like this. So when we simplify the denominator, we have -1, and that is going to be equal to x plus the square root of x squared plus 1, and then this is going to be plus x minus the square root of x squared plus 1, because this negative and this negative will become positive. Alright, so you see that this and this will cancel out beautifully, and what you are left is 2x. So a just simplifies to 2x. Cool. Now let's look at b. So b, if we can recall, is this guy here, x plus the square root of x squared plus 1 plus 1 over that. So b is x plus the square root of x squared plus 1 plus 1 all over x plus the square root of x squared plus 1. We are going to do the same thing here to see what it will be. So here we are going to rationalize the radical. So x minus the square root of x squared plus 1 all over x minus the square root of x squared plus 1. Okay, so b here is going to be x plus the square root of x squared plus 1, and then plus multiplying this one is going to be x minus the square root of x squared plus 1 at the numerator, divided by difference of two squares. Again, you have x squared minus x squared plus 1, and this one is going to be equal to x plus the square root of x squared plus 1, and this one is -1, which will make this one negative. So that is going to be minus x minus the square root of x squared plus 1, like this. So b is going to be equal to, so here the x and the x will cancel, right? So x here is going to cancel -x here. Then we have this one plus this, because this times this is going to be positive, right? All right. So that is going to be equal to 2 times the square root of x squared plus 1. So this is what A is simplified to, and this is what B is simplified to. So now we can just replace them in our integral. So our integral I is going to be equal to, when we go back up here, that is going to be 1/2 ln of this times A. So 1/2 ln of x plus the square root of x squared plus 1 multiplied by A. So this is multiplied by A, and A is simplified to just 2x. So A is simplified to 2x like this. And then what is left? Minus 1/2 times B. So that is minus 1/2 times B, right? So minus 1/2 times B. So minus 1/2 times B. And what is B? B is simplified to this. That is going to be what? 2 times the square root of x squared plus 1 plus the constant of integration. I is going to be equal to, see that 2 is going to cancel 2, and then this 2 also cancel this 2. Everything is cancelling out beautifully. Then you have x, which is this one, multiplied by the ln of x plus the square root of x squared plus 1, and then minus the square root of x squared plus 1 plus the constant of integration. And this one matches the answer that I gave in the beginning of the video. So when we go to the top, you see that the answer I found down there is exactly equal to the answer I gave in the beginning of the video. So apart from using Euler's method, you can just recognize that this function ln of x plus the square root of x squared plus 1 is the same as the sine hyperbolic inverse of x. And using integration by parts, you can easily integrate this. And the answer to that is x ln of x plus the square root of x squared plus 1 minus the square root of x squared plus 1. So this is how to solve this. If you don't know that this one is the sine hyperbolic inverse of x, then you may have to use the Euler substitution to solve this one nicely. So that is the method that I wanted to show you. If you really enjoy this video, please give me a thumbs up and consider subscribing to Calculus Diaries for more engaging content on integrals. Thank you so much for watching this video, and I will see you in the next one. Bye bye.